Hi team, Mr. Rator here. Okay, today we're going to look at discriminant. So it goes here, find the values of the parameter m for which the quadratic mx squared minus 4x plus 2m is equal to 0. Okay, now, is equal to 0 has equal roots. Now, first of all, discriminant will come from the quadratic formula, and the discriminant is b squared minus 4ac. Okay, so this is discriminant, which is the root in the formula. So this discriminates against how many roots we have. So you should know that already, that if the discriminant b squared minus 4ac is equal to 0, this implies it has equal roots. Okay, the equation will have equal roots. B squared minus 4ac, when it's greater than 0, since you can square root, this is a positive number, it has two roots, two different roots. Okay, and two different real roots, we can even say. And b squared minus 4ac, when it is negative, less than 0, has no real roots. Okay, so we've got three scenarios here. Now, going through this question, we need to look at the coefficients. A is the coefficient of x squared, b is the coefficient of x, and c is the constant. So in this case, a is equal to m, b is equal to minus 4, and c is equal to 2m. And we need to find the value of m for which this equation has equal roots. So we need that first scenario. I'll call this scenario 1, 2, and 3. So we need the first scenario here, where we're going to sub this into this formula and make equal to 0. So we got minus 4 squared minus 4a is m, and times by c, and c is 2. And this is going to equal 0. So we get 16. M times m is m squared. 4 times 2 is 8, so minus 8m squared, and that is going to equal to 0. So I'll put the minus 8m to the other side, so I get 16 equals to 8m squared. You can rewrite this if you want as 8m squared equals 16 shared by 8. That gives me m squared equals 2. The opposite of times is divided by. So m, find the values of parameter, m can equal plus or minus square root of 2. Okay, so pretty straightforward. Just sub it into the formula and you find out what the value of m is going to be. Now, let's look at some more questions further down. Okay, find the exact value of k such that the equation is equal to 0 has repeated roots. Now, repeated roots are the same as equal roots. Okay, so repeated root is the same meaning repeated. This has the same meaning as equal roots. Okay, so repeated roots, equal roots, same. So let's go through and again discriminants, write down the discriminants as b squared minus 4ac, and this time it's going to repeat the roots, is going to be equal to 0. In this case, we got a equals coefficient of x squared is minus 3. B is equal to coefficient of x, which is 2k plus 1, and C is equal to minus 4k. Now, what we're going to do is sum these into our equation. Excuse me. So we get 2k plus 1. We're going to square all that. Minus 4 times a, which is minus 3, and times c, which is minus 4k, and that is going to equal 0. So if we expand this out, we're going to get this squared, which is 2k squared is 4k squared. Now you should know the easiest way to expand this out is just 1 times the k and then double it. So 1 times 2k is 2k, double it is 4k. And then we get the end value, which is 1 positive 1 squared is 1. And then there's times all that. So first of all, minus times minus is positive, times minus is going to end up negative. So 4 times 3 is 12. 12 times 4 is 48. That's going to give me k, which is going to equal to 0. So looking at here, we're going to end up with a quadratic equation. So we're going to end up with 4k squared. So plus 4 minus 48 is minus 44. Okay, and then we got the plus 1 here equals to 0. Okay, we'll struggle to factorize this, so we're going to use the quadratic equation. So in order to find k, again this will equal a, this will equal b, this will c in the quadratic equation. So we will get k equal to minus b will be minus 44. That's coefficient, okay. Plus or minus square root of b squared. In this case, it's going to be minus 44 squared. Minus 4 is c, 4a is 4, and c is 1, all over 2a. This could be 2 times 8. Now you could just simply plug this into your calculator, as your calculator can solve the equations in a slightly longer way. So we're going to get 44, 2 meters make positive, plus or minus, if we do 44 minus 44 squared, minus 4ac it's a 1, sorry, close bracket. Okay, so that's going to be take away 16, which we're going to end up with square root of 1920 over 16, and this will come out to be 44 plus or minus 8 root 13. You could simply just do this on your calculator. Simplify all this, so as you can see, 4 will go into all of these, so k will equal 4 into 44 is 11, 4 into 8 is 2, root 30, all over, and 4 into 16 is 4. So that's what we'll do. final answer for exact values of k. So you've got two values, one is the positive and the other is the negative. Okay, like I said, you could just put this straight into your calculator, this equation, and it will solve it straight away. Okay, so let's have a look at this one. Find the range of values of the parameter c such that this equation is greater than or equal to 0 for all x. Okay, for all values of x. So what this basically is telling me is that if we got this equation, if we had an equation like this, and if this was the curve, if I had a curve like this, I'll get two values, okay, two roots, and it crosses the x-axis. If I got a curve like this, this is what we call repeated root, where it only has one root, one value. And if I've got a curve like this, it has no real roots, okay, it's above. So since this is a positive quadratic, it's always above this line, it's always greater than, or yeah, just greater than 0. But we want the scenario where it's going to be greater than or equal to 0, so it can touch the line, this line where y is equal to 0, the x-axis. So it can touch that line, but it has to be either touching it or above it. So that means it can have one root, a repeated root, or no real roots. So we say that the discriminant in this case, b squared minus 4ac, is going to be less than or equal to 0. So equal to 0 will give me the repeated root, and less than 0 would mean there are no roots, so it's always above. Okay, it does not cross this line, there's no roots there. So again, that's the first thing to establish. Now let's do this. For a equals coefficient of x squared is 2, b the coefficient of x is minus 3, and c the constant is 2c plus 1. If I sub this into our discriminant, I'll get minus 3 squared minus 4, a is 2, c is 2c plus 1, and we want to solve it for less than or equal to 0. So we're going to end up with 9. First of all, that's going to be 8 minus 8. Minus 8 times 2 is minus 16c. And minus 8 times positive 1 is going to be minus 8. It's going to be less than or equal to 0. So add those together, we get 17 minus 16c is less than or equal to 0. Bring the minus 16 to the other side, so 17. So the minus 16 becomes plus 16. That gives me 16. Oh, sorry, just a miscalculation here. Just double check here that 9 minus the 8 is actually not going to be 17. It's going to be 9 minus 8 is going to give me 1. Okay, just double checking that. So taking the minus 16 to the side leaves me with 1 on here. So let's just quickly just double check that. This was 9 squared, 9. This is 8 times 2c. Minus 8 times 2c is minus 16, and minus 8 times 1 is minus 8. 9 minus 8 is 1, minus 16, and then you get that by taking that to the side, and therefore c is going to be 1 divided by 16. So c is greater than or equal to, we can also write this as c is greater than or equal to 1 over 16. So that would be the range of values of the parameter c in this function is greater than or equal to 0 for all values of this. Find the set of values of k for which this equation has no real roots. No real roots meaning that the discriminant b squared minus 4ac is going to be less than 0. So again, let's just look at it. In this case, a is going to be 1, b is equal to minus 2k, c is equal to 6k. Sub it into the discriminant, we'll get minus 2k squared minus 4, a is 1 and c is 6k, which is less than 0, so that's going to give me 4k squared, and 6, 12, 18, 24 minus 24k, which is less than 0. Now I could just simply divide everything by 4, so k squared minus 6k is going to be less than 0. Then I'm going to factorize this, which is going to give me 4k minus 6 less than 0. Now when we're solving inequalities, it's best to sketch a quick graph on the other side. So let's just sketch this graph. Now one of the roots is going to be here, going through. So let's just, one of the roots is at k equals 0 and k equals 6 is the other root, and it's a positive quadratic, so it's going to go down here and coming back up. So that's 0 there, 6 here, and we need to know when is the graph below 0. So we want all this part of the graph is below the 0 line. So that tells me these are the values. So this is k this time. Okay, so k is going to be less than 6 and greater than 0. Okay. So we can write this as k is less than 6 and greater than 0. That's it. Straightforward, simple. Straightforward, and I would say simple, just part of substitution and summarizing and linking it back to quadratic inequalities. Okay, same thing here. It goes find the range of values of k for which the quadratic has no real roots. Okay, so first of all, has no real roots. B squared minus 4ac is going to be less than 0, and we've got coefficient x squared is a, which is going to be k in this case. Coefficient of x is b, which is going to be minus k plus 3, and the constants here is c equals minus 1. So if we sub these into here, we get the minus, when we square it, will disappear, so we get k plus 3 p all squared minus 4, a is k, and c is minus 1. That's going to go less than 0. Well, that's going to be less than 0, not equal. So let's just expand this. Simple way, k squared, 3 times k is k, double it is 6k, so that's k squared plus 6k. 3 squared is 9. 2 negatives make a positive, and that's going to be, just end up as positive 4k, which is going to be less than 0. So now we're going to get k squared, 6k plus 4k is 10k plus the 9. When is that less than 0? So we can factorize this straight away. 1 and 9, k in each corner, 1 and 9, and they're both going to be positive. It's going to be less than 0. So we've got 2 roots here. Again, doing questions like this, it's always best to sketch graph. Just going to go through it's going to go through -1 and -9. The graph is positive, so we're going to be going through, the curve's going to be going up and then back down up here. This is -9, this is -1. So we want all the values for which this curve is below 0. So that's between here when it's below 0. So in all the values when k is between -9 and -1. So in fact when it's less than -1 and greater than -9, the answer here will be k is greater than -9 and less than -1. Right, same again, very straightforward. Find the values of m for which the equation mx squared plus mx minus 2 has 1 or 2 real roots. 1 or 2 real roots. So again, 1 or 2 real roots, that means b squared minus 4ac is going to be greater than or equal to 0. So when it's equal to 0, it'll have 1 real root. When it's greater than, it'll have 2 real roots. Again, let's just write here, a is m, b is m, and c is equal to -2. So a is m, b is m, and c is equal to -2. So let's just sub it into this discriminant. So we got m squared minus 4, a is m, and c is -2. When it's greater equal to 0, we're going to end up with m squared. 2 negatives is going to become a positive. 8m greater equal to 0. Factorize this, take m out. You got m plus 8 greater than or equal to 0. Again, let's just draw the graph. So it's going to go through 0 and -8. It's a positive graph, so the parabola is going to look something like this. And we want all the points, so it's going through 0. We want all the points where this equation, this graph, is above or equal to 0. So that's where it's above or equal to 0. That's where it's equal to, and therefore it's above. So in this scenario, we want m when it's greater than or equal to 0, and we want all the curve for which m is less than or equal to -8. Okay. We want everything which is less than or equal to -8, and everything which is m is greater than or equal to 0. Okay. So find the possible values of m such that this graph is less than 0 for all values of x. Again, when the graph is less than 0 for all values of x, let's just have a look at this. So we want this equation, we want all these points where we want them to be less than, the graph to be less than this line for all values of x below 0. So again, we want the graph where the discriminant is going to give us, there's going to be no solutions here, so there's going to be no roots, because we want the graph to stay well below 0, so it's not going to hit that line. So it's going to be, basically we want the discriminant b squared minus 4ac to be less than 0. Okay, have no real roots. That's what we want it for. Okay, so let's start straight away. First of all, A equals M, B equals 3, and C equals -4. If we put this into our equation, we get 3 squared minus 4 times A, which is M, and C, which is -4. We want that to be less than 0. So we get 9. 2 negatives make a positive, gives me minus 16. Minus 6. 2 negatives become positive, so 4 times 4 is 16m, which is going to be less than 0. Okay, so now let's just take the 9 to the other side by negating it. So 16m is going to be less than -9. And then we're going to take this m to the other side by dividing it, so m is going to be less than -9 over 16. Okay. So just remember this, just got to be careful when we're going through something like this, realize what the discriminant is going to be. So the discriminant, we didn't want the discriminant to have no real roots. Okay, so we put it as no real roots, so it does not cross this line of 0. So constantly this graph for all values of x, these are the values of x, all values of x, this graph will be below the x-axis.